All right, let's do some notes on it. Keep that right there. We'll need this here in a second. I can make it work. That's what's important. I don't know what Lisa did. Probably messing around with the interview. Got her head roasted. Okay, so this little bad puppy right here. It goes to another standard model one that I have somewheres in here. I'll just dig for it real quick. This bad puppy right here. Standard model right there. There are actually anti-up and anti-down, but they generally give you the standard model because that's what does. And an object at rest is going to stay at rest. It's not going to do anything in here. An object with any geometry in this way, up, anti-up, strange, anti-down, positive electron, new electron, the new mu, and the new tau. Those are important because it's a decimal thing. The smaller you go here to those three balls I normally give you, somewhere around in here, are a type of what that is, right? So, yeah. But when you think about it, it makes a lot of sense. Given that hydrogen and helium are what's up, and there's an anti-up nature to it, in that the four the S, P, D, and F orders, that you have this positive charge, right? That it's positive in the way it reflects, or is what is it? Chiromancy, not chiromancy. Chiral to the issue on what it is, but there's only two topologies, right? It can be this zero, don't cut the danger noodle, don't break the danger noodle. You could maybe argue that I needed to throw some pins up inside of here. Not only is this, it has to be universal, right? I kind of need it to do, there's an S1 order with some of the geometry. It's what's up, it's what's down. When you give the Bohr model the energy it needs, it's going to release energy. It's going to be a positive charge in that way, or if it emits it, it's going to be a negative. And that negative arrow would be a relative nature to the causal nature of time, but a charm. This is up, this is down. Because there's that momentum after that Laplacian here on the Taylor series, that's at rest. That's what it wants to be, real close to that core. It doesn't necessarily have what it takes to break out of that shell with the right energy, with what's going on convectionally around it, that maybe one of those drop in there for the Holloway limit there. He was doing red giant stars for the triple alpha process. Well, making this is, again, you're going to have to understand this side of it. You're going to have to understand this side of it, equally like there would be any science that would go to it. I want a chart on the Born identity that says I'm dealing with the prior past. There's some element of what's up in its energy. That was me determining its up and down cycle. It's still a function, but the way it's ranging requires some charge differentials with energy, because you just can't put in energy that way, right? So that might be its pin here, but by knowing that cycle when it comes in, you get a much more precise idea with chemistry and the molar masses and things like that, that if I try potassium nitrate, sodium nitrate, and lithium nitrate, or sodium oxide, sodium hydroxide, potassium hydroxide, nitrogen, or lithium hydroxide, apparently for whatever type of reaction I'm looking for, there's a math to it that says, well, it's roughly energetic, but when you put it into this solution, it might go exothermic or endothermic with a photon or a gluon in that way, that can change this bosonic state into a fermion. That, once we get down here to the second order of what this form is, I'm going to say that is the Tylenol to the aspirin to Tylenol reduction, right? In Nile red over here. That's at rest. We don't know what that is, but as we chart those out on a time sequence, we're going to start with the shell number where it's already configured here and doesn't have that quite a billion. You need equipment and money and time and figuring that out. But basically, that is the up down charm energy that you would need in a negative ultraviolet problem here, catastrophe, that deals with the way to strong force this, right? You see it a lot on what the internet is. I would tell you that there was this model, but it's much more precise. You're dealing with spinners and everything else. That's a weak force. If you can see it from there, there's the math. Send it right here on Forbes. They'll put up some card up there with the numbers and points on them. You're looking at the weak force. People aren't really good with that, but there's a glitch with it, right? That's what this is. There's only two topologies. It's this closed little loop and some configure of that against something else with those changes. And as it's going to heat death. That's what's going to happen. There's fusion, magnetism, black holes, and other things to consider. But we can do that down here. We can say, well, that makes sense to the limit of black holes, right? They wouldn't want to do that. That magnetism would pull them back around, and then that would have that hydrogen-helium aspect that wraps it back around, so I can understand how lithium, still in the first order, would have that concept. Here, again, hydrogen 4, or helium 4, and this boron makes a lot of sense now, right? Because I want to make carbon. But there's a lot of other emissions at that first level. But nobody's really ever tracked me through it, and I try my best to grind through the YouTube.
Is in fact a law, but it doesn't belong to Newton. This is sometimes called Galileo's law. Although Galileo's statement was slightly different, what Newton calls motion is what we call today momentum. But
there's other ones out there you'll find about Newton and Dirac and other things lately, but you know, if you believe in the universe to be this perfectly sinusoidal wave function, then you're going to get in problems about why you collapsed or had such a shear force in your system, right? You know, that was not necessarily, it was more of an antimatter collision inside of a neutrino affected. There was a gravitational lensing that all the numbers were right, but because of the pressures and environment, it subtly changes sea level. And as long as sunshine doesn't mind, that's not going to change anything because the upper bounds inside of those areas haven't changed. So that's at rest, you know.
But this law was also stated by others before Newton in terms of momentum. So while this is a law, it cannot be attributed to Newton. The second law in its written form is very long, but...
All right, let's just take a look at it. F in motion, a ray, some kind of way to quantify me in the stone mill, a chemist doing an example, Nile Reds, Tylenol to aspirin. One, our general model. That's still an operating system. Electron, the biggest, right? We know that's what it is before we get to the standard model, this decimal difference here to the tenths and the hundredths, and it works for change and everything else. That's a strange. Out there in the real world, the value of the stone I'm pushing is determined by the t, the movement value by units, over the derivative in time. How many times have I done that in the past, from a positive past, a negative past, a negative past, and as it's operating, how am I doing right now? From that point in t, the tau, the fact that that's acting as that notation, and it's high on the bar, because you need the highest, lowest energy state that you can get, not necessarily the smallest aspect of that. All right, well, anyways, that's kind of that whole helium shell right there, hydrogen cell. I'm probably missing the cell model, and I gotta have to hack at the standard model until I figure something out that looks real good with this, but it would probably go up here, and this drops a level. And that has to do with that other z function. Again, it's just weird geometry. You can't necessarily trust any configuration except for line and potentially dot, and then watch that thing bang around on here by what curvature is going to come around on that operating system. You're generally looking at it first.
Notice again that
going
motion
back
here
from that
refers to
Laplacian.
momentum. It might be Newton's. The concept of force
Trying to figure out the anti. Well,
but
took those kind of castings, but I don't have that. I want a better
matter,
reaction.
though, because this is not a law.
I kind of need that wiggle room.
So at best, this can only be called Newton's definition. The third law is in fact Newton's. However, this is not a law. It's a direct consequence of the first two. So this one should be called Newton's corollary.
Chirality is going to be really important, especially when you think about the triple alpha. These people are shaking hands. They work in the covenant. When you're dealing with the exclusionary principles of Bernoulli about why it's going to be E, I, pi down here, most of them figure out the strong force. This is not just, you know, up here, you're still in the ranges of making money. You might even have enough. You would know, thinking about it, whatever I'm doing, up would be able to correlate that, but most people, especially in the early entry of that learning curve, they're coming in from their house model, they just quit their job, they started on the day, no matter what they do, they don't make money until that first week, right? That starts to turn over maybe the second week, but your skills have changed in here. And so those units are really super important, especially down here, shaking hands in danger. It's one of those jokes you get to say. Then there's that snowflake that comes down here, and then like the Hallway and all the other four that go with that fit really, really good into a Bohr model like that when this thing starts to come back around about that unit squared circle problem, integrating the gravity and time to the situation. Because then we can start trying to say, well, all right, gold slit experiment and shooting it at the wall. I'm using this wave function, curve, spinners, and I knocked it one way or the other, right? That is right there. Come in the stone mill, dude. You're gonna start burning it, and that's like going through that accretion disk before convection comes around, right? It just wants to be this uniform temperature. You could even argue because of this, I might have made some mistakes, right? It may want to be in that way where Bohr did it better or something like this, but hopefully I can get something worked out here. Maybe even like that's the positive and this is the negative. It needs to be in that chirality as well or something.